JPA stands for Java Persistence API, and it's a like what we were just talking about, right? It's a technology that allows us to abstract the mechanism of mapping, right, relational databases to an object data model, right? Because a lot of the, if you write a lot of this code using JDBC, you find yourself that the code looks very similar over and over, right? You have all these CRUD operations, right? And once you've written 5, 10, 20 times, you say, oh my God, this all looks the same, right? If I could somehow parameterize this, right, and instead of having to write the same CRUD operations for students and then the same CRUD operations for courses and then again for sections and then again for departments and then again, right? Once you've done it a couple hundred times, you see you find a pattern. It says, well, if you could just give me the name of the table, right? I could instead of you coding student, course, section, right? You just tell me the name of the table, and instead of when you read the when you're writing the fields or when you're reading the fields, right? If you could just give me the names of the fields, right? I could just generate for you the select statements and the inserts and the updates and the deletes, right? If you just gave me the names of the fields, I could write a very generic implementation of these CRUD operations, right? So that you just need to parameterize me and I work for everybody, okay? And that's exactly what ORMs in general do, right? ORMs in general, what they do is that, hey, here are the 5 general CRUD operations, yes? And you can just parameterize me. Give me the name of the fields. Give me all their data types. Right? Give me the names of the tables. Give me all the relationships. Yes, and how I should interpret them. Is it a one-to-one? Is it a one-to-many? Many-to-many? Is it a mapping table? What are you doing, right? And then it just provides for you an API that allows you to interact with the relational database. Right, but without actually interacting with the relational database, right? It allows you to stay in the object world, right, as close as possible, with minor knowledge that it is indeed going to a database. So JPA, again, it's the latest incarnation of Java's attempt to normalize the access to databases. Again, its first attempt was with EJBs, and then and it was people hated it. There was a lot of alternative implementations, particularly the one by Hibernate that caught on very much. It became very, very popular amongst developers, and which simplified this mapping between objects and the relational database. And eventually they were part of the specification team that came up with what we have today as JPA, right? A lot of the you'll see a lot of similarities if you look at some older code from Hibernate. You'll see a lot of the same ideas that are in there in JPA. Okay, it's all part of the JavaX persistence package. All the classes I'm going to be talking about today are in that package, and there's four different concepts that we need to understand. One is a persistence unit. Is where you configure and say, well, these are the classes that I want to be managed, right? That they're going to have a class name. Obviously, they're going to have all the fields, all the properties of those classes, and by default, right? What JPA is going to do is says, okay, well, by default, I'll take the name of the class and I'll assume that there's a table with the same name, right? And I'll take also the Java Bean names of all the fields, and I'll assume that there are fields in the table with the same exact names, right? And it'll make best guess at the data types as well, right? If you have integers, strings, right, dates and whatnot, right? It'll make a best guess on what you want them to be represented in the relational database, right? As varchars and integers and whatnot. Okay, where it needs to have some guidance is with those things that are not particularly one-to-one, right? In particular, the relationships, right? When we have foreign keys and primary keys that we want to implement, those are not necessarily evidence, right? So we need to configure how is it that we want to implement certain things that we can do in object orientation we can't do in relational databases, right? So we have to specify some, how is it that it should be implemented in the relational world, right? Entities are going to be the equivalent of classes, right? So we're going to just work with plain old Java objects, right? In the Java world, in the object world, and we're just going to annotate it. So this is an entity, right? And that means that's going to give a clue to the JPA framework that this needs to be mapped to some table, and the fields to some, and the properties to some fields. The entity manager is going to be the mechanism by which we're going to interact with the database by telling it that, hey, we want to store this object that we have in Java, we want to store it in a database. That'll invoke either an insert or an update, right? If we're persisting something that's already in the database, it'll be interpreted as an update. And JPA will be smart enough to know whether it should be an insert or an update, right, if it's already there. And the persistent context that will keep track of these instances that have been already loaded from the database, right? And it'll keep track of their life cycle. If objects have been loaded from the database and if they're modified, if their state changes, it'll know that it needs to go back to the database and synchronize whatever is stored in RAM and whatever is stored in the database, right? So the entity manager is going to be the main mechanism that's going to allow us to interact with the database, such as allowing to read. All the CRUD operations are there, right? You can read, you can write, you can update, delete, and close it, and also some transaction management as well. So find, persist, remove, merge, and close. We're going to be configuring any class that needs to be synchronized, any object, Java class that needs to be mapped to some table in the database will need to be registered in the persistence.xml. So for instance, here we have a developer, an application, courses, sections, right? They will be all listed here in class, right? And we give the entire set of classes that we're persistent. We are collecting it in what is called as persistent unit, right? So that later on in code we can say, well, which one do you want to work with? What persistent unit could be you want to work with? And you can have different persistent units pointing to different databases. So for instance, if you want to migrate or deal with multiple databases, multiple connections, you can have a persistent unit pointing to MySQL, another one pointing to Postgres, another one pointing to a NoSQL database, right? And you can work with them independently. Here too is where you configure some of the low-level stuff, right? So what vendor are you using, right? If you're using MySQL or SQL Server or Oracle, what driver are you using? What's the URL, any username and passwords that you would configure here, so that none of it is in code, right? Again, what Java's trying to do here is that your source code should work regardless of what vendor you're using underneath, right? If you should be able to plug and play the vendor, right? You should be able to switch from Oracle to MySQL with no changes to the source code, right? You presumably you code once, run anywhere. That's the mantra. And these XML files is what abstracts all that connectivity, right? It's abstracted outside of the source code and into some configuration files. So some system admin would modify this, right? So some deployment engineer would change this, right? But not the developer. The developer would not be responsible for doing these kinds of things. From the developer's point of view, they only would need to be given the persistence unit, right? What persistence units are we using, right? And that's exactly what we're using here to abstract, right? What are we using underneath? This all would point to the fact that we're using a particular vendor, a particular username and password, a particular environment, right? Perhaps you would have different XML files depending on the environment you're deploying, right? You would have perhaps one for development, another one for QA, another one for production, right? And you would have pointing to different versions of the database, different logins, right? For that you're working with, right? And perhaps one for local as well. So it all starts with the entity manager factory that allows you to instantiate an entity manager that from a particular persistence unit, right? Once you have an entity manager, you can start working with persisting or retrieving things from from the database. So it all starts with creating a persistent an entity manager factory, and from that factory you can instantiate an entity manager. Once you have the entity manager, you can start interacting with the database by saying that you want to start a transaction. Right? You say, I want to start a transaction, and everything that is in that transaction should be considered an atomic operation. Right? Maybe I want to insert over here, read over there, delete over there. Right? And all these things are being cached, right? And they're not made permanent until we decide to make it commit. It says you're committing, and says, okay, now I want to make all these changes permanent, and they are then written to the database permanently. Right? So it all starts with a begin, and it ends either with a commit or a rollback. Rollback just puts it back to where the database was before you started the transaction, and we'll talk about transaction a little more next week. So here's an example on inserting or persisting or writing something to a database. You're giving an object, whatever that object is. So this would be a plain old Java object, right? So this would be a dumb Java object, right? Just with setters and getters, right? And all the attributes, all the properties in there, maybe a couple of constructors, and that's it, right? So the application would be just a simple Java object. And from within your DAO, you would grab the entity manager, you would start a transaction, you would just persist the object, and then you would just commit, and that's it. Right? So the only interesting part here is that the persistence, right? That persists. That's it. That inserts the data into the database, mapping, grabbing from the name of the class, it knows which table. Looking at all the field names in that class, it would know which fields in the table. Okay, and even any relationships, right? If there are foreign keys and primary keys, would also be written. Well, if you configure it correctly, you can configure that things are cascaded, right? So that if I save a parent, it would also save all the children that would go along with that, right? And would follow all the primary keys and foreign keys to all the other records. Find. Find is again, it's a very generic find method, and it would it understands that it would be finding by some primary key, right? And so you would have to tell it, because it doesn't know which table to search from. You have to give it the class of that you want to retrieve, right? And from that class, it will derive what table it needs to search it from, right? And also in that class, we'll see in a minute, we would need to configure, right? What is the primary key field, right, in that class, so that it would know that 20 is against that particular field, right? And we instantiate that department. Typically, this would have to be casted. Oh, actually, no, it doesn't need to be casted because it knows the class, right? Internally, it casts it to the correct data type. Okay. So here's here's our finder, right? Again, it grabs the entity manager. It begins the transaction, and it would use em find to retrieve the application from the database. Creating new instances, you would create an instance of the Java object, right, and would just pass it into the persist, and persist would know how to insert it into a database, right? Wait, did we just look at this? I think this slide is repeated. Removing entities. You can give it, so from the point of view of object-oriented, you are removing objects. You never actually work, right, with records, right, from JPA, right? You only work with objects. So if you're removing, you would iterate over a collection of objects, right? And you would ask the entity manager, hey, I'm removing this. I want to remove the record, right, that maps to this object that I have in RAM, that I have in memory. And if I have a collection of those objects, right, I can iterate over them, and I can remove them one at a time. .remove identifies what is the ID that was associated to that particular instance that would load it in memory, and with that ID, we'll go and remove them. Yes?
So when it's performing the commit operation, does it require some sort of lock on the database? Because say there are two or more classes that are working on the same object.
Yep. Yeah, there's a lock. They're locked.
There would be a lock while the commit is going.
Yes, and you can configure the level of locking that you want, right? And we'll talk about transactions next week. But you can say what level, whether it's optimistic or pessimistic. Right? So pessimistic says you lock everything. You lock the table, and you have the table all to yourself, right? Or optimistic, where you're saying you can lock just the record, right? Only the records that you're working with, so that any other threads that want to work with the same exact record would have to wait, right? But pessimistic would say, no, I lock the entire table, have it to myself, right? So anybody else who's doing anything with that table would not be able to. And there's several other layers where you would say, I allow reads, but I don't allow writes, right? Or you can configure what level of how severe you want it to be. Anything less than pessimistic would allow certain inconsistencies, and that would depend on your application whether you can live with those inconsistencies, or how would you recover from those inconsistencies, or some inconsistencies are just would not ever occur in your application, so you don't even care to guard against them. But again, we'll talk about a little more about transactions next week. And all that would be configured in the persistence.xml. You would configure all the level of transactions that you want to handle. So here's an example where we persist an instance of Edward and Frank. We load them, we store them in the database, right? And then we just remove them, em.remove, using the instance of the object that we have in memory, right? That we have in RAM. And the persistence layer keeps track, right, of this instance that I have in RAM is mapped to that record that I have in the database, right? So that if you call remove of some instance that is in RAM, it'll know, oh, it's that record over there. I'll do a delete on that record in the database. Now, oftentimes we will need to interact with a little bit a little closer to a database, right? Where we might, the finder methods that we have here that we want to retrieve something by ID, oftentimes that's not enough, right? Maybe we have some more complex criteria by which we want to retrieve things, right? Maybe we want to retrieve those employees that were are making more than between a particular salary range that have been with the company so many years and whatnot, right? So you would have to provide some query, right? But we don't want to actually go down to the low-level SQL. Instead, we have a higher-level query language, right? That's object-oriented, an object-oriented SQL, right? What would that look like? So here, for instance, we have delete. We want to create a query that says delete from developer dev where dev.id equal ID. That looks very, very much like SQL. Okay, very, very close. But here, developer is not the name of a table, right? Instead, it's the name of a class, right? And the .id is actually a field in that class, right? Not actually a field in the table, right? So even though this looks SQL, looks like SQL, it's not actually SQL. It's JPQL, right? It's Java Persistence Query Language, which is an object-oriented version of SQL that gets mapped to a low-level SQL depending on the vendor, right? And you can change the vendor, and depending on the vendor, you will generate different SQL, right? And you can not only configure the vendor, you can also configure the version of that vendor or the dialect, right? Because there's many dialects of SQL, right? And depending on the dialect that you choose, right, it will generate different SQL for that particular vendor. So that here at the level of the developer, we don't need to deal with those idiosyncrasies, right, of a particular vendor, a particular version, a particular dialect, right? We would be completely isolated from the low-level SQL idiosyncrasies. You can handle also rolling back, where you can go back to a previous state before the entire the entire modification or interaction with the database would be, so that we can go back to a stable state. So anyway, so how do we create these objects? So we're going to create just plain old Java objects, Java classes, but we're going to annotate them, right? We're going to give them some clues. We're going to give some clues to the JPA infrastructure on how is it that we want to map these classes to some low-level tables, right? So for instance, all classes will be annotated with the entity annotation, right? And we can specify the actual table we want to map it to. You can leave it just with entity. The table is optional, right? If you just say entity, it will use the default name, right, of the class. It'll map it to a table of the same name. Or you can specify exactly what table you want to map it to by saying table and then the exact name you want to map it to. We're going to also identify the primary key and say what field do you want to use as a primary key. Okay, so the only two required annotations are entity and ID. Those are the only two that are required. The other ones, table, column, many-to-one, and so on and so forth, those are all optional depending on what you want to do. For instance, column, you can annotate each one of the fields, each one of the properties in the class, and say that, hey, I want this field, this property in the Java class to map to this particular field in the database, right? If you leave it, right, if you don't give it any name, it'll default to the Java Bean property name, right? So if you called it name in set name, get name, right, in Java, it'll create a field of the same name. Right? Many-to-one and one-to-many. These are to deal with primary keys and foreign keys, right? And we'll see examples of that. So here's an example of a very simple POJO, right, plain old Java object, where the student class has been annotated as an entity, and the SID has been annotated as an ID. That's all. Those are the only two required fields. Okay, but certainly we would like to annotate a couple other things. For instance, we have enrollments here. Probably that's like a many-to-many, right? One-to-many. So there must be some kind of relationship there, right? And how it's implemented in the database. Notice that there's several ways to implement it in the database, right? It could be that enrollments just has a foreign key back to the student, right? Or enrollments is actually a mapping table, right? That has two foreign keys, one that comes back to the student and one that goes back to the section. And because there's several ways to interpret this, that's why we need to annotate it, right, and give it some more parameterization on how do you actually want to map it into a database. And that's what we mean by the impedance, right? There's an impedance here because there's not necessarily a one-to-one way of implementing this in the database. So here's a student. We're adding a couple more annotations. Here we're specifically saying that we want to use the student table. Here it's kind of redundant because it would already be mapping to the table called student anyway. So there the table annotation is kind of redundant. Here actually most of these are all redundant. Here we are mapping the SID to SID, SName to SName. They'll be mapped to probably all caps, right? All caps, SName, graduation, all caps. Major ID here, we have notice that this one is also another relationship with an instance of a department. Right here, we're saying that there's a foreign key that this is being implemented as a foreign key back to the department. So internally in the relational database, there will be the department will have a foreign key, right? That is called major ID. Okay, so somewhere there'll be some kind of foreign key that maps this to a major ID. Here's a one-to-many saying that we are on the. Okay, no, this says that we are participating in a one-to-many relationship or many-to-many relationship, and we are on the one side, right? We are a student, and there are many enrollments on the other side, right? So there are many enrollments on that side, and we are on the strong side of a weak to strong relationship, right? We are on the strong side, and the enrollments is on the weak side, right? And on the enrollments, presumably there is a field called student, right? Whose data type is student, who's referring back to me. Okay. Okay, this one is saying we are in a many-to-one relationship where the department is on the strong side. There's one department, and there's many students on this side, right? So this will be implemented internally. It will be implemented as an ID, right? As a foreign key that references the table that is representing the department. So if you open up the database, there won't be an actual field called major. Okay, there will be a field called grad year. There will be a field called S name, but there won't be a field called major. There will be a field instead called major ID. Okay. Students, there's a couple constructors and the setters and getters. Nothing interesting there. Annotations. Right, so these are the major to ones for foreign keys, or the inverse relationship one-to-many. We talked about that. Default names, the tables, they can be omitted, and it uses the class name, and the column could be omitted, and it uses the field name. Persistence configuration, we do that in the persistence.xml. It must be in the class path, and you just list all the classes, right? All the classes that you are mapping to the database. And also the low level description of the username and password, what drivers you're using, what vendors you're using, what dialect you're using, things like that. Often depending on on what kind of queries you're using, you'll need to create queries, right? That can deal with more complex references to actual records in the database, but they're object oriented. Here's a simple one: select S from student S, right? Where S is an instance of a class student, right? And you say S dot graduation year, and then some just very much like a prepared statement, right? That you can put placeholders. Placeholders can either be number, like over here, right? Placeholder 1, 2, 3, 4, and so forth, or colon and then the name of the placeholder. Either one works, right? Obviously, the named one is a little more easier to document of what it's doing. So here's an example of using them in joins, right? Here's a select s dot star. Actually, no. This is what you would do. This is how you would do it in SQL, right? Where you would have foreign keys equal to primary keys, right, to do the joins, right? So for instance, here we're joining 4 different tables: students, enrollments, sections, and courses. And the way we traverse we navigate through these is that we make the primary key of one equal to the foreign key of the other, and then the primary key of one and then to the foreign key of the other, and so on and so forth, right? Now in JPQL there are no foreign keys, no primary keys. Everything is object oriented. Instead, we know that the objects are going to have actual pointers, actual references to each other. Right? Where here we're saying that the enrollment will have a student field of type student, right? That should be equal to the S, the student. So retrieve from me all the students that match the enrollments with that student, and also that the section in that enrollment matches some enrollment K, where the course of that section equals the course whose title is basket weaving. Right? Notice that there's no foreign keys here, no primary keys. Right? It's an object-oriented way of saying exactly the same thing. Right? But notice that there's some redundancy here. Notice that this e.student and e.section is actually part of the same object e. Right? So those can actually be collapsed into one. You can navigate them. For instance, you could say, you could collapse all those 3. You collapse all into a single one. Notice if you're joining just students and enrollments, you can navigate. You can use the dot pointers, right, the dot notation, to navigate from one instance to the next instance. You can say e.section.course.title equal basket weaving, which is pretty cool, right? This is following all the foreign keys and primary keys, right, and joining them all together, right? It's creating all those ands for you, right, without you actually having to write them, right, which is pretty cool. Right, yeah, path expression is exactly what we did. You can also return now in SQL. It's very common, right, that you're returning several fields from different places, right? Some fields from one table, or not some other fields from another table, right? And it kind of builds like a record on its own, right? And then typically in the result set, you can say, well, give me the first one, the second one, or the ones that have a particular name, right? Over here is a little different. You can retrieve, since these are objects that you're returning, not fields from a relational query, right? If you're returning students and sections and grade, right? The way it works is that it creates for you an array, right, where it will put all the results for the first object in the first element of the array, of the result array. It will put all the data for the second result in the second element of the array, and so on and so forth. And then you can ask, well, give me the first one, the second one, the third one. So here's an example. Here we have the query select eStudent.eSection.eGrade, where the enrollment year offer was 2007. Right. So this first one, these are three things that are going to be retrieved that can be queried. Create the query, and then it returns the result list, and you can iterate over that. And each one of them will be part of a different element in the array. So if you want the first one, we'll get the student. Notice that this is an entire student object, right? With all the fields of the student are there, right? And here's all the section fields are there, right? All the grade. Well, this one is just a field, right? So notice that the first one, we're casting it to a student, so we have the entire student of the first query. So this over here, right? I'm retrieving it right there, and then the section, it'll be part of the second element in the array. Here's the second element, and we're retrieving it and casting it to a section object. And the grade, grade is a section? I thought that was going to be like a string or something. It is a string. Oh, so that's wrong. Thank you. So here's an example of creating a table for an application. And I don't believe I use it later. All right, no, this was talking about implementing enumerated data types, but using tables as opposed to the enum. Since enum in MySQL has some performance hits, right, and also it will work only with the databases that support it, right, and since JPA was trying to implement an implementation that goes across any vendor, right? So it uses an implementation for enumerations that is portable across all vendors. Here's just a dump of some of the communication with the low-level SQL, generating all the SQL data. So it generates the queries to drop the tables, to create the tables, to insert, and we'll see that in a minute. We'll do some examples on you doing this. All right. All right. So let's try and code some of this, and some demo this live. All right. Let's do that now.